So today's video is going to be about percentage yield. We're going to see how all the concepts that we have studied so far come together over here. So what is percentage yield? It's actually the percentage of the actual amount of the product received, obviously after the reaction. So the percentage of the actual amount of product received compared to the amount theoretically calculated. So you can perform some theoretical calculations and find one amount, but the actual amount is going to be different from that. So it is actually a ratio of the actual yield, the one that you receive after the reaction, divided by the theoretical one. The theoretical one is going to be the one that you calculate times 100. Obviously, the actual is always going to be lesser than the theoretical one. The actual amount cannot be guessed, you can't know it. So the question, the examiner gives it to you, while the theoretical yield is something that you can use your working for. You can find it using your own ratios, using your own molar calculations. So calculated using molar ratios or obviously your formula. So when we talk about it, let's try some practice. The question says, find the mass of iodine produced by using 300 centimeter cube of the oxygen gas. So we don't have the mass of iodine with us, but we do have the volume of the oxygen gas with us. So we know it's a three-step process, right? Because we first find the moles, which is unknown for oxygen gas. So mole is equals to the volume of the oxygen gas divided by 24,000, which is 300 is divided by 24,000. It's going to be equal to 0.0125 moles of oxygen gas. So we first found the moles of oxygen gas because we work in moles, not in volume or something else. Now we want to create a ratio between oxygen and iodine, which is 1:2, because 1 mole of oxygen gives you 2 moles of iodine. So it's going to be 1:2 ratio. Now 0.0125 moles of oxygen can give you how many moles of iodine? It's just going to be a simple cross multiplication. You're going to find out that moles of iodine is going to be equal to 0.0125 times 2, which is equal to 0.025. So this is the moles of iodine that you find over here. Now we are not concerned with the moles of iodine. Rather, we wanted the mass of iodine. So mass of iodine is going to be equal to molecular mass of iodine times mole. So we need the molecular mass. For iodine, which is a diatomic molecule, it's going to be 127 times 2. 127 is the atomic mass, times 2 is 254. So 254 times the moles, which is 0.025, is going to be equal to 6. Yeah. So it's going to be, I estimated it right. It's 6.35. I am good at mental math, by the way. So it's going to be 6.35 grams. This is the theoretical yield. We calculated it using our entire methodology. We used a three-step process. So this is the theoretical yield. But the question part B says, find the percentage yield if only 3 gram iodine was produced. So the actual amount of iodine that you get is 3 grams only. So percentage yield, formula for that is going to be equal to, percentage yield is equals to actual yield or the actual amount divided by the theoretical times 100. So we have the actual amount with us, which is 3 grams, divided by 6.35 grams of iodine, which was the calculated amount, times 100. Your actual is always a little lesser than the calculated one, so it's going to be somewhere around more than 50%. Less than 50%. Yeah, it's 47.24%. This is the actual yield. So your reaction reached 47% completion. Let's try this question. It says, find the mass of potassium sulfate produced if 20 centimeter cube of 0.6 mole per decimeter cube reacts with excess potassium carbonate. Now obviously it's the data for sulfuric acid, because sulfuric acid is aqueous and we have the volume and the concentration for sulfuric acid. We are not bothered with potassium carbonate because that is excess. So we don't have the mass of potassium sulfate, but we do have the data for sulfuric acid. So let's first find the moles of sulfuric acid. The formula for an aqueous solution is equal to mole of sulfuric acid is equal to concentration times volume divided by 1000. So the concentration given to us is 0.6 mole per decimeter cube. Volume is 20 divided by 1000. So it's going to be equal to, divide by 1000. Yeah, it's going to be equal to 0.012 moles of sulfuric acid. So we have the moles of sulfuric acid with us, but we want it for potassium sulfate. So using a 1:1 ratio, 1:1, we get that sulfuric acid and potassium sulfate have a ratio of 1:1. So 0.012 moles of sulfuric acid can give us how many moles of potassium sulfate? The same, which is 0.012 mole. But again, we are concerned with the mass of potassium sulfate, not the moles. So the third step is going to be same. Mass is equals to moles times molecular mass. We know the moles are 0.012, but what is the molecular mass of potassium sulfate? So we can say it's going to be equal to 2 times the potassium, 1 times sulfur, and 4 times oxygen atoms, which is 2 times 39 plus 32 and 4 times 16, because 16 is the atomic mass of oxygen atoms. It's going to be equal to 32 plus 64 plus 2 times 39, 174 gram per mole. So this is the molecular mass. When you find the mass, it turns out to be something 2.088 grams. This is the mass of potassium sulfate theoretically calculated after your mole ratio. The question in part B says find the percentage yield is 70%, they've already given it to us, but find the mass actually produced. So the actual mass is unknown, but the percentage of the completion, percentage of the achievement is 70%. So percentage yield is equals to actual divided by theoretical times 100. Now we don't have the actual amount, but we know that the percentage yield is 70%. So 70 is equals to the actual divided by the theoretical, which is 2.088 times 100. If we make actual the subject of this equation, it's going to be actual is equals to 70 divided by 100 times 2.088 grams. So obviously the answer is going to be smaller than 2.088, and it's turning out to be 1.461 grams of potassium sulfate. So see, actually it's lesser, but theoretically we calculated it to be more. Now let's do one more question. It says brown vapors of nitrogen dioxide gas are produced when calcium nitrate decomposes. They have given us 400 grams of calcium nitrate, so this is the mass. Mass of calcium nitrate is 400 grams. This is the mass, not the moles, by the way. Now they want us to find the percentage yield if only 75 gram of calcium oxide was actually produced. So this is the actual amount of calcium oxide. We first find the theoretical yield by the 3-step method. So calcium nitrate mole is going to be equal to moles is equals to mass divided by molecular mass. 400 gram is the mass. Molecular mass is going to be calcium plus 2 times the nitrate, which is 40 for calcium. Nitrogen is 14, 16 times 3, which is 48 times 2. It becomes 40 plus 62 times 2. So it becomes 62 times 2 over here. Then it comes out to be 164 gram per mole, which is the molecular mass of calcium nitrate. When 400 grams is divided by this molecular mass, it turns out to be something around 2.439 moles of calcium nitrate. Now the ratio between calcium nitrate and calcium oxide has to be found, because these are the reactants and the product. So it's a ratio of 2:2, which is obviously going to trickle down to 1:1. So it becomes calcium nitrate to calcium oxide 2:2 ratio, which becomes 1:1. So 2.439 moles could give us exactly 2.439 moles. Now this is the moles, right? We needed the mass. So in order to find the mass of calcium oxide, what we're going to do is we're going to times the mole with molecular mass. So for calcium oxide, the molecular mass is going to be 56, because it's 40 plus 16, right? So 2.439 times 56 is going to be 136.58 grams of calcium oxide. Now this is the theoretical yield. For the percentage yield, we know that actual divided by the theoretical times 100. Actual was 75, theoretical is 136.58 times 100. So 75 divided by 136.58 times 100 is going to be 54. I was so close, 54.9%. So this is the percentage yield. I hope this idea is clear to us. In the next class, we're going to be talking more about their past papers. So stay tuned, guys. Thanks.